All right, so this learning objective, we're going to learn some factoring shortcuts. So factoring quadratics, like I said in that video, is a really important skill to have. But there's a couple cases where you're going to save yourself some time and not have to go through the whole process. A lot of times people will teach this first and then do the other method, but then students always just remember the shortcut method and not the original. So I really wanted to hammer down the original method and then figure out these shortcuts. All right, so you can only use these shortcuts in very specific cases. All right, so make sure you figure out what those cases are and only use them then. Don't overuse shortcuts, because that's kind of one of the most common mistakes students make. They learn a shortcut for one thing and want to use it for everything. All right, so let's just do this problem the way we were doing in the previous videos. All right, we need to find B is 5, AC is 6. Right, because there's a invisible 1 in front of that x squared. All right, the numbers are going to add to 6, or sorry, multiply to 6 and add to 5 are 3 and 2. So you can write this as x squared plus 3x plus 2x plus 6. All right, first pair, I can factor out an x. Second pair, I can factor out a 2. I get x plus 3 times x plus 2. All right, and the shortcut we're going to see for this first example is, if you look at their answers, we have a plus 3 here and a plus 2 here. And those 3 and those 2 are the same as the initial 3 and 2 that we got from there. We didn't have to really do anything extra. That 3 and that 2 hang around. All right, so this is going to end up being the shortcut. All right, and the shortcut only works in this case. All right, so it's really important. When you only have a 1x squared, you can do the shortcut. All right, so we'll do this one the long way, confirm the shortcut, and then we'll use the shortcut from here. So again, we'd have to find two numbers that add to -5 and multiply to give 6. All right, in this case, it's going to be -3 and -2. Do the same thing. I factor out an x from the first pair, a -2 from the second pair, and we get x minus 3 times x minus 2. So again, you can see the -3 here turns into this -3. The -2 here turns into this -2. All right, again, all this can only be done because we just have a single x squared. All right, so don't forget what we learned in the last learning objective of being able to do this process here. But now when we just have a single x squared, we can go directly to the answer. All right, so here we have x squared minus 5x minus 24. All right, B is -5. AC is -24. And the pair of numbers that's going to multiply to -24 and add to -5 is -8 and 3. And our shortcut says our final answer just uses those numbers. And we can only use the shortcut because of that. So the shortcut only works for x squared, but once you figure out your perfect pair of numbers, you basically have your final answer. All right, so here's one for you to try on your own. Again, you could do it the way we learned in the previous learning objective, but I kind of want, in this one, try to use that shortcut, all right, and figure out how you're going to factor this quadratic. And when you do it, your perfect pair of numbers is -4 and 3. So we put those in here, and we get our final answer, x minus 4 and x plus 3. And again, if you FOIL this out, you'd see it's the same as the top. All right, so a really important note I mentioned earlier in the video, you can't overuse this shortcut. If you wanted to factor something like this, you cannot use the shortcut because there's a number in front of x squared. The only time you can use the shortcut is when you just have an x squared all by itself. So just remember that, but when you see that it's just an x squared, I kind of be happy because you get to do a little bit less work. All right, we're going to learn one more shortcut in this video. So x squared minus 9. First of all, you might notice this is similar to our previous shortcut. It's that there's a single x squared. This won't always be the case, but in this first example, it is. But what is b in this case? There's no x term, so it looks like there's not a b. And the reason is I can rewrite this as x squared plus 0x minus 9, right? Multiplying something by 0 makes it disappear. So my b is actually 0. And my AC is -9. All right, so I'm looking for two numbers that add to 0 and multiply to -9. That's going to be -3 and 3. And again, since this is one of the ones we could use our previous shortcut on, I'm going to get x minus 3 times x plus 3. Now this shortcut might not be as obvious. Again, we kind of used the previous shortcut, so the negative 3 and 3 are there. But one thing that is nice is that these numbers are the exact same. One's negative, one's positive, but they're both 3. All right, this is going to end up being the shortcut is that when you have this difference here with just these two terms, you just take whatever number multiplies by itself in those spots. All right, so if I wanted to factor x squared minus 16, all right, this is the exact same form as last time, and you can kind of do a little bit of guess and check for now. We'll get better at doing this in the future, but 16 is 4 times 4. So I'm going to factor this as x minus 4 times x plus 4. All right, so this is a shortcut. This thing is called a difference of squares. All right, difference of squares because x squared is a perfect square. 16 is 4 times 4. It's also a perfect square. And then difference because there's a minus sign. All right, so this difference of squares, you can factor pretty nicely. You just take, well, x times x is x squared, so that's going to go with the first term. 4 times 4 is 16. That goes in the second term. And the only thing you have to make sure is that one has a minus sign and one has a plus sign. All right, so this is our shortcut for these differences of squares. All right, so here I changed it up a bit. It doesn't look like we can use our shortcut anymore, our first shortcut, because we have a 4x squared. That's not a single x squared. All right, but this difference of squares shortcut is still going to work because 4 is 2 times 2. X squared is x times x. And 25 is 5 times 5. And so everything we have in this problem is something multiplied by itself, which means we can still use this difference of squares shortcut to say this is 2x minus 5 times 2x plus 5, right? Because 2x times 2x is 4x squared. 5 times 5 is 25. All right, so this is a difference of squares, which means you can use this secondary shortcut. We can factor a difference of squares. And again, as long as we have 1 minus and 1 plus, that is the solution. All right, one more example. All right, 81x squared minus 4. Again, the kind of thing to check, there's a difference. Are both of these things perfect squares? Well, it turns out 81 is 9 times 9. 4 is 2 times 2. All right, so once I recognize these things are perfect squares, I can factor them like this. Again, I'm going to keep mentioning one's minus sign, one's a plus sign. So here's one for you to try on your own. 16x squared minus 9. And here's the solution I got. So 16 is 4 times 4. 9 is 3 times 3. So if we factor this difference of square, we get 4x minus 3 times 4x plus 3. And again, just like our first shortcut, it's important you only use it when you're able to. So we can only use the first shortcut when we had just a single x squared. We can only use this one when we have a difference of squares. So again, they both have to be perfect squares, which just means something multiplied by itself. Like 4 is a perfect square because it's 2 times 2. And it has to be a difference. It has to be subtraction. We cannot factor x squared plus 4 because there's a plus sign instead of a minus sign. So x squared minus 4. I don't know why I'm writing in the highlighter mode, but I am. X squared minus 4 would factor as this. X squared plus 4 we just can't factor at all. All right, so make sure it has to be a difference in order to factor it this way. All right, so now go ahead and practice these shortcuts. Again, when you're practicing the shortcuts, don't forget about the original way that we learned to factor in the previous learning objective. All right, but in terms of future classes, future examples in this class, knowing these shortcuts will save you time and effort when you recognize that you can use a shortcut and then use it appropriately. All right, just make sure you don't overuse the shortcuts.